Okay, today is our last pandas lecture, at least for now, until I think of new topics to teach. But today we're talking about string operations. Um, okay, so just like some current announcements. So assignment 1 was released. It was made by me. So some of the questions probably have like some spelling mistakes. I already caught one on like the first question, but it's okay. And like yeah, if any of the questions are like vague or worded weirdly, just feel free to contact me at this phone number. Also, if you didn't get the assignment, literally just message me your email on Zoom right now. Yeah, and I'll send it to you at the end of lecture. I'll send to you at the end of lecture. And then okay, you can also just message me on my phone if you didn't get it, if you're like watching the recording. So, and then we'll go over the solutions next week. Oh yeah, and then a side note is after next week, we're gonna take a 2-week pause because of AP tests and finals. Okay, so right. Before we talk about string operations, I want to talk about like potential problems with data. So the very first thing, well, this is the vocabulary, right? So this is what's known as scope, right? So like a question you have to ask yourself when you're doing data analysis is, will my data be enough to answer my question, right? So like, for example, if you want to access Alviso's air, but you only have data measurements from your house, right? That this is probably not enough data to answer questions about Alviso's air, right? Or another follow-up question is my data too broad, right? You're looking for like Alviso's water data, but you only have data for California. And this exact scenario is what happened when I was looking at Alviso's water data earlier. Right, so the solution to this is you filter the data. There's also a notion called temporality, which I should probably know how to pronounce it, but I guess it's okay. And it's about, is your data in the correct time frame, right? So if you look at the water data that I sent like ages ago, you realize that like if you want to look at Alviso's mercury data, they're all from like 1980s. Okay, and that's probably not very helpful for a paper about Alviso's mercury now, right? Also, I just want to mention this, January 1st, 1970, if you ever see this, that is actually normally a replacement for a null value. Because this is when it's 0 in Unix time, so I don't really need to explain Unix time. It's just know that like this is like a suspicious date, right? January 1st, 1970. And 2000 was also one, but that's like less suspicious. Another big question is what's known as faithfulness, right? Or it's like, how accurate is my data? And it's important to note in the real world, perfect data is never obtainable. Okay, like the baby names data set. Okay, yes, that's like real world data, but it's very like complete and very convenient to use, right? However, in the real world, you'll have data with like lots of holes. You have data with spelling mistakes. Units are inconsistent. You have no idea how often this has happened to me. Okay. Right. Sometimes I don't know why they do this. They like duplicate rows or they like truncate data. And the most important of all is context, right? So in this like little graph here, in a lot of contexts, this might not be suspicious, right? But for example, if, I don't know, this line was amount of water in the fish tank, right? This would obviously not make much sense, right? Because, that whole thing doesn't make sense. But anyway, this like would not make much sense because like water wouldn't act like this, I guess, right? Or like, yeah, for example, if you have an H column and the value is negative, right? That's obviously not correct, right? Yeah, so as mentioned before, a lot of your data will have like holes in it. Okay, so what do we do about that? And there's 3 general strategies that data scientists use. The first one is the simplest of all. You simply just drop all the missing values. However, this oftentimes loses too much information. What I mean by that is, in a table, you're going to have like hundreds of columns, right? If a single one of them is nan, you'd like delete that row entry. Well, then you just lost the information on the other 99 columns, right? And a lot of the time, a not a number or nan actually means something. A recent example is when I was looking at restaurant data, and a lot of the restaurants like coordinates were nan, right? And I noticed later on that the nan values were normally associated with things like food trucks, right? Because they didn't. Oh, sorry, because they didn't really have a location, right? Like things like that, right? Another option is you can simply keep as nan. I mean, you're not doing anything then, but yeah, you can like do it. And the final thing is sort of what everybody does. It's called imputation, which just means you try to guess what the missing values are, which I know sounds like very irresponsible, but it's actually like way more effective than like what you might initially think. There's like a bunch of types of imputation, which I will like not specifically mention, and you don't really even need to know how to do. Just kind of know that it exists. And oh, okay, I guess average imputation, I mean, it's like fairly simple. You simply just replace with the average value in a subgroup, right? So you like sort of determine which row entries are like the most similar to this one, and you take the average of that. But like for example, this graph here, you see like November 16th is missing, but you can like somewhat infer what the data is, right, from this graph, right? It's not like you have no idea, which is why like imputation is like sort of like a very powerful idea. But yeah, as mentioned, imputation is very complicated, right? So like imagine you have like hundreds of thousands of missing data, you're trying to imputate like all of them. So yeah, so just like keep them as nan for now. If you like ever run into like this missing data problem, just know that if you want to look into it, there's definitely ways to like upgrade your data, if that makes any sense. Okay, finally, the main topic of today, string operations. If you're maybe like somewhat familiar with string operations, you already know it's gonna be a bad time, okay? Because string operations are like very infamous in all coders, like for all coders. So first of all, okay, so like why are string operations even important? I just said it was very tedious and like very like everybody like sighs at the thought of it, right? But like why is it important? Why do you need to know how to do string operations? Well, one, so it's known as canonicalization, right? As mentioned before, your data is not gonna be perfect, right? So what if we have two different representations of, for example, California, and you try to merge these two tables together? Well, the merge function has no idea that the CA and California represent the same thing, right? Because the merge checks for exact string matches, right? However, so then, well, you can't just like shrug your shoulders and say, oh, I can't merge these tables, right? So a string operation would be to sort of replace this California with CA, so then you can actually merge it. Another reason why it's very important is you can extract in a more detailed way. So like, for example, the most like canonical example is extracting dates out of log files, where like log files look like this thing, which like not really human legible, but you want to get out this date, right? And I want to get this day, month, year out, and I want the hour, minute, and seconds out of the log, right? So this is like a very common application of like string operation. Oh, another very common one is data would like come in a paragraph, for example. Like you're like you have a survey table, and one of the columns is like a free response question, and you have like a giant paragraph, and you're trying to like extract important information out of that giant paragraph, right? So that's when you'd like sort of extract in a more detailed way, is sort of what I'm letting at here. So just like the recap from Python, just like there's a bunch of string operations in Python, which luckily do transfer over to pandas, right? One is just string.lower, just set everything to a lowercase letter, string dot upper, set everything to uppercase letter, string dot split, right? You split the string into whatever with like you split it with whatever like character or phrase you put here, and then you like get a list of the split. And there's an in, right? So you can check if this substring is in the string. There's a replace, right? You can replace things or you can delete things. I mean, you can just replace like a certain pattern with nothing, right? So delete it. There's like slicing that I think I mentioned before, and length. If you're unfamiliar with these, that's okay. Just like sort of make sure to, I guess, get a rough idea on what they do before you like move on to pandas. However, Python string operations only work on one string at a time, right? So notice this one string. I can't call dot lower on the whole list. I'd have to iterate through the whole list. Right? Luckily, Pandas offers a method of what's called vectorizing text operations, which is this str operator, the series.string, right? So you can just think of it as applying the string operation to every entry in the column, right? So like for example, right? So if we have the column baby names, or we have the table baby names, and we have the column names, and I want to call I want to lowercase everything in the column. I just simply call dot str and then dot lower, right? It's important to note that if I want to chain multiple string operations, like I want to like maybe do a split after this dot lower, I have to call dot str again, right? So this dot str is per string operation. And you'll see this is a very common pattern with this dot str and then dot string operation, right? So you can imagine you can replace literally like dot str and then dot replace and the dot str dot split, right? And you can apply that to everything in the column. Okay, yeah, exactly what I just said, right? So most base Python string operations have a pandas string equivalent, right? So you can do like series.string lower, you know, series.string replace. For instead of in, you can do like series.string.contains, right? Etc. etc. Right? Yeah, so it's like, yeah, it's actually like directly transferable, actually. So the most important thing about strings, like, is what's known as string extraction, right? You have like this jumbled up string and you're trying to extract a pattern out or like a subset out, right? So in the log files example, how you do this in normal Python, I guess, notice that this is only one string. Okay, so this is already very simplified. I'm just trying to do this for like a list of these, right? So you'd have to do a line. You'd have to, okay, assume this string is called line, right? So you'd have to split by these brackets, then get the 0th entry and the 1st entry, then split by this, then split by this, then split by this, right? To finally get the result we had earlier, which was like this, right? Day, month, year equals this is this, yada, yada. Now, I don't think anybody wants to code like this, right? And especially if every column entry is unique, imagine like trying to come up with like a new thing per row, right? That's ridiculous, right? So this code is very verbose. For this should be like a very simple string extraction, right? It's like normally like a pretty easy case, right? But also further imagine that there's like an extra pair of brackets. So this first split statement is like wouldn't even work, right? If even one of your columns had it, right? Or you can consider this problem. Try to extract this moon, right, substring from here. Okay, how would you like even begin to write code for that, right? It's like deemed extremely, it's like pretty much impossible, right? So we need like an alternative way to extract strings. Introducing regex, regular expressions. People also say rejects, but I think regular expressions means regex, right? But regex, despite its fancy name, is literally just nothing more than pattern matching, right? And note that you have to import this what's called RE, so you can like have R type strings. So like for the code we just looked at, we can use one string, which is a pattern, and sort of call this, well, I'll explain everything throughout the course of the slide, but it's like give you like a general idea, right? You can one pattern, I can extract all 7 of these values just with one pattern, right? I know this pattern looks like very confusing for now, which it is, but you'll go to see that this is like maybe a lot more simpler than like what it looks like, I guess. Now this is the most important point of this lecture. Regular expressions are not something you memorize, okay? Most people, like me, just simply know it exists. And when we use it in practice, we refer back to the guide, okay? So if you were to ask me to extract day, month, year, hour, minute, second, time zone, right? I would be like, okay, wait, let me consult my guide and get back to you, okay? Because I don't remember all this, like all these like little rules. So it's just important to understand what you could possibly do with it, right? So like what it's capable of, right? So like I said, do not remember the small details. Just remember like a general idea of what I could do, or like take away a general idea of what I could do, right? Yeah, so like a formal definition, a regular expression is just a string that specifies a search pattern. So for example, here, again, I'll go into all of these like cases very soon, but this just means 0 to 9 3 times, right? So this means like 3 of any digits, then a dash, then 2 of any digit, then a dash, then 4 of any digit. So if you just imagine this as English for now, so just think of this as 3 of any digit, dash 2 of any digit, dash 4 of any digit. This would match with social security numbers, actually, which are like 3, 2, 4, right? So it would match with like this or this, but it would not match with like this, right? Because there's like 4 character or 4 numbers here instead, or with this because there's no dashes in it, right? So this is like sort of the idea of regular expressions. I want to extract this, but not this or this, right? I want to extract this pattern. So we formally start defining different parts of regular expressions. The first 4, so this is just concatenation. Okay, so look for consecutive characters. This literally just means match as is. You can think about it like that. So AA, BAAB, right? If you put this in a pattern, it will only match this, AAB, AAB. Okay, it will only match this. It'll be looking for this only, and it'll only match this, right? There's also another operator, this like bar called OR, right? Which is very similar to Boolean logic. I simply say I want to match this or that, right? So if you can imagine, I have like a string with like AA, C something something, I would match the AA. But if I also have a string with BAAB, A something something something, I would match this as well, right? So it's matching this or that. And this will sort of become a lot more clear with examples, which we'll get into very soon. This star operator means match 0 or more times, right? And this is per character, right? So if I say A, B, A, that just means I match, I look for the A, then I can match as many B's as I want, and then an A, right? So what this would match is AA, ABA, and then A, B, 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 A, right? And then there's also parentheses, which just means consider it as a group, right? You're like grouping everything together, right? So in this example, if I were to put A, B in parentheses, then start, that just means I want to match 0 or more ABs instead of just B, right? In our previous example, right? And then it ends with A, right? So this would match with A, right? Because ABA appears 0 times, or ABA, for AB, BA, yada yada, right? And then I can put this parentheses around here, which will map A, then A or B, then A, B, B, right? So it matches into these two things. So these three things are called meta characters, right? They represent an operation rather than a literal text character. And if you want to represent, if you like, for example, you want your string, you want, for example, this asterisk, right? You put a backslash before it to specify that this is like the character that I want rather than the operation. Yeah, so this is like a sort of table to basically represent what I just said, except you can think of this as just PEMDAS. Okay, so what takes priority? Parentheses will definitely take priority. Okay, then the star will take priority, then concatenation will take priority, and or, very importantly, will take last priority. Right, so you can imagine like in this case, AB will be grouped first, then the star will be applied, right? In this case, this will be grouped first, but then you have the or, right? Oh yeah, okay, so here we go. This is why everybody's like very scared of regular expressions, because there's just like so many different type of characters or like rules, right? So I'm just gonna hit you. I'm basically like hitting you with like pages of text, and it's like I said, impossible to memorize. So do not memorize it. Just like I guess get the gist of it, right? There's also a period, which just means look for any character. Actually, do I have an example coming up? This okay. I mean, okay. Well, I guess I'll get to the examples when I mention like the square brackets and stuff. Okay, I guess here is an example, right? So okay, I guess not, because you still need to know a little more for the example. Um, okay, well, I guess the examples are in the slides, but that's okay. Okay, we'll go back. Okay, sorry for like the scuff lecture, but okay, so there's also a period which just means match any character, right? And this means like any one character, right? So dot u dot u dot u dot u just matches any string with use in these three places, right? And then there's also the square brackets, right? Which this defines a character class. Now, what this means is that basically I can put like a dash z and then a dash lowercase z in these square brackets, and this will match with basically any letter, singular letter, right? Uppercase or lowercase. And I think I do have, yeah, character class in the next slide. Character class examples in the next slide. There's also plus, which is one or more, which is slightly different than the star, which is zero or more. There's also a question mark, which is 0 or 1. You can think of this as like optional, basically, but obviously it cannot be more than 1, right? And then this is like sort of what we saw before, which is like the flower bracket x, which means repeat exactly x times, right? So AB and then this flower bracket 2 will match the ABB only, right? And then there's also like x and y, which means repeat between x and y times, right? So AB02, which match AB, A, AB, and ABB. Yeah, this is just saying that there's many ways to like say the exact same thing, basically, right? So if we look at like this previous example, right? So this 0 to 9 is a very famous or very common character class, as I mentioned. Actually, okay, yeah. 0 to 9 is a very common character class, right? So this is basically saying match 0 or 9, 0 through 9, exactly 3 times, right? So that just literally just means any 3-digit number, right? Then this dash is taken literally, right? It's not a special operation, so it's looking for exactly the dash in the string. Then it's asking for 2 digits right? Exactly 2 digits only. Then it's looking for the dash. Then it's looking for exactly 4 digits, right? So this is like sort of the rough translation of what's going on, right? And yeah, as mentioned before, so this is exactly why it would match to this, but not this, right? So it's like sort of give you like an insight on like how we can like match social security numbers for some reason if you wanted to do that. Yeah, so what are the different character classes we can have? These are definitely the most common ones. Just any, like for example, this just means any uppercase character between A and Z. There's a 0 to 9, which I just mentioned. There's A to Z, A to Z. You can like put multiple in one bracket, which means just any letter, any digit, right? So it's like all 3 of them. You can regular expressions also have built-in classes, right? So there's like \w, which is just equivalent to any character, any digit, or any letter, any digit. There's /d, which is equivalent to any digit, right? And /s, which just means white space. Yeah, it's match white space. A note about character classes: you can add a caret to inside the character class, which just basically means match to everything except for the characters in that character class, right? So this would match to anything that is not A through C, right? Equivalent, oh yeah, there's also capital versions of the character classes from before. Although, okay, sorry. Okay, the capital versions of the regular expressions are actually negations. Okay, so /w just means anything that's not a letter or digit, right? So that would be like maybe a percent symbol if you're looking for that, right? And this just means anything that's not a digit, and this just means anything that's not white space. Yeah, so this is like what so far what we just looked at, right? Where like the period just means any character. You'll see like the dot paired with the star quite often, which literally just means any character 0 or more times, right? So literally just means anything. For like, so like if you're trying to like get a middle of a string, you'd put like dot star, which means like put anything before that, and then get like the middle part, right? Yeah, you're gonna importantly apply a star to a character class like this, right? So this is basically saying any capital case or lowercase letter, then 0 or more characters or letters, lowercase letters, right? So matches to be like word or like capitalized, right? But these two would obviously not match, right? Because this is a capital letter and there's a 4 in here, right? And we've already looked at these, like repeat exactly 8 times. Yeah. Also like the at least 1. So this like sort of puts a restriction on the star. And this is basically equivalent to saying 0, 0, and then star, right? It's like the same behavior. Oh yeah. An important thing to know, I don't know why I put this in the middle of it, but it's okay. Regular expressions are greedy, which means that it will always match the longest possible pattern, right? So there's a very canonical example. This is because like this is very popular in other like languages where it's like you have this like dash div, right? So let's say I want to match exactly this caret div caret, and then any character in between as many times, 0 or more times, right? So any character is 0 or more times. Where I mentioned before, like the dot and star are like normally paired together, right? And then it ends with this, right? So the goal is to sort of extract this guy and this guy. However, what it does is it looks at this, then it says any or more characters until I see another div, right? So it will see this, it says, okay, great, I have a match. However, it will keep looking, right? And then it'll realize, okay, there's another one here. So this would be another match, right? Because technically, this caret / div caret is part of any character, right? And this is still under the definition of 0 or more times, right? And then it'll keep looking and finally find this one, which is the last one, and it'll match this entire string instead of what we wanted before, which is like this and this, right? So this is like a very important idea, especially when we're going to talk about like regular expression operations. You'll see that this matters like quite a bit. But just keep in mind that it's greedy. And this is a very, if you ever have regular expressions, right, you can just open the subject on regular expressions 101, regex 101, right? And this is like sort of the end all be all website, right? That's like what literally everybody uses, because I guarantee you nobody is good at regex. Okay? Like I haven't met a single person that's like, oh man, I'm like proficient in this. Everybody, and I mean everybody, opens this up, puts their string in here, see if their pattern matches. They double check if their pattern matches, right? And regular expression, regex 101 will tell you exactly if it will match or not, right? And you see it's very helpful, right? You can hover over this and it'll tell you exactly what's going on, right? So the period, like render form, matches any character, or the star matches 0 or more times, right? And so like this is the string that I put in, and this is like the pattern I'm trying to match. Yeah, so like I said, regex 101, go-to tool for everyone. So yeah, be sure to use this if you're struggling in regular expressions in the future. Yeah, so there are slightly more symbols. I think this is the last group of symbols. Yeah, okay, it's the last group of symbols. So it was like not terrible. There's only like 10 symbols or something, which is kind of bad, but oh well. Yeah, as mentioned before, this is the backslash, which just means read the character literally. I do not want it to be like a special character, right? So in this, for example, A backslash plus B matches to A plus B, right? So instead of A one or more times, then B, right? And then there's also a caret. They have notation overload, which I like really hate. I don't know why they did this, but they did. This caret also means match the beginning of the string. If you put this in the square brackets, that's what negation would be. Okay. So if it's not in a square bracket, that just means match the beginning of the string, which basically just means that it must start with over here, right? The string that you're matching must start with here. So if you look at this 1, 2, 3 space ABC, this does not start with A, so therefore it will not be a match. This $sign just means match the end of the string. In your pattern, it must end with this character, basically, right? So ABC space 1, 2, 3, it will not match because the end is not C, right? Very simple. Yeah, so this is like a little overview table of what we just went through, right? So if it starts with, this means it must start with this, right? So arc2 and arc would match, but this would not match, right? And you can similarly look at end of line and escape characters, right? The exact same thing. Okay, finally, we went through all the text I just read you. And finally, we can see some examples of this actually being useful, okay? So remember the security number example I talked about earlier, right? So let's say I have this long string, long text, and I want to, I'm like trying to hack into their system, and for some reason they just have their security numbers in a string, and I want to sort of extract their security numbers, okay? So if we use the pattern I discussed earlier, which literally just means any digit 3 times, any digit, or dash, any digit 2 times, and then any digit 4 times, right? Every time I see this match in the string, if I call this find all operation, which I will define formally right now, actually, it's basically gonna put in a pattern. I take in a text, and it's gonna output in a list every single time it matches. Okay, but as a reminder, it's greedy, right? So be aware of that. You might end up with like long strings because you didn't realize, you didn't consider the greediness, right? So this will output a list of all the matches, as mentioned before, right? However, what's most important is that .str in a series also allows for regular expression functions, right? So what that means is that I can call .str.find all and then the pattern. So I can basically apply this find all operation, this pattern match, to every single column or to every single row in the column, right? So let's say I have this data frame, I just call it SSN, I've got these bunch of things. I call str.find all, right? It'll look into this entry, it'll take out all pattern matches of this, right? So meaning 3 digits, dash 2 digits, dash 4 digits, right? So it'll take out this and I'll put it in the list, right? In this row, since there's no matches, I'll put in empty, right? And here, in this third row, there's 2 matches, right? So I'll put both of them. So that's the general idea, right? So you can think of it as just applying this pattern match to every single column individually. Then every single match it gets, I add it to a list, right? So importantly, this returns a list. Okay, yeah. So if you like, for example, only want the first match, right? Because you still want it to be a string at the end of the day. It's very abnormal to have like lists inside of a series, right? You can like do a dot str then put a bracket 0, right? Saying I want the 0th index of the list. Okay, there is another version of notation overload, which again, I don't know why they designed it like this, but I'm not the designer of this. And I think it's very stupid that things can mean like multiple different things, but parentheses can also mean capture groups. Now, what this means, capture groups just means that I have a pattern that I want to match, but I only want to output a specific part of the pattern, right? So for example, if I want to get the hour, minutes, and seconds of this, like here, then what I'd do is I would say, okay, I want any character 0 more times. Then I want 2 digits, right? But notice these parentheses, right? So this means that in the final output, I only want to output these 2 digits. Right? Okay, well, there's also parentheses here, right? So I only want to output these digits, these 2 digits, and these 2 digits, which basically means I do not want to output the colon, this colon, or any other of these characters, right? So if I were to call find all on this text with this pattern, what I would output is this, right? Where I get 08, which is this capture group, then 30, which is this right here, 2 digits, then I get 00, which is 2 here, right? Notice this output is a tuple. I'm not sure like the specific reasons why it's a tuple, it just is. So if you have like multiple capture groups, more often than not, you're gonna have a ginormous pattern to like sort of look for what you're finding for, but your capture group is like a very small part of that, right? So like for example, if you have a long essay, like for example, if you have like housing data and they have like a description column and their description includes like the number of bedrooms, right? And you want to extract out the number of bedrooms, right? What you do is you'd have your pattern match like X bedrooms, but I would only put my capture group on the X. So when I output it, it will only be that X, right? However, note that this means what I'm basically saying is I will only extract out the X where the pattern matches, right? So it's not like I'm extracting random integers. I'm extracting out the number of bedrooms in this case, right? Yeah, like I said, so notice the colon is not being captured because I didn't put it in the capture group, is what it's called. There's another function called extract, which, I mean, intuitively, right? extracts out information, right? What this actually does, or like what it more formally does, is it returns a data frame. Okay, not a series, a data frame of each capture group's first match in the string. So if we look at our same old pattern, right, but was 3 capture groups this time, then we call string.extract, right? If we look at this right here, it'll output this data frame, which looks a little confusing at first, but the 0th column is, what it means is it's the first capture group, right, for all 4 of these rows. Right? So if you notice, the first capture group is here, 3 digits, anything, right? So it'll be 97, right? And then here it'll be 123, and here it'll be 99. Note, as mentioned before, this is only the first match in the string. So this like 3, 2, 1, 4, 5 thing gets lost, okay, in this extract statement, right? So if you want to add this as well, there's a function called extract all, which is it returns a multi-indexed data frame, which just means you have this index and then another index that's like sort of specifies this. And you can look into more details about this, but I've like personally never used this before. Yeah, just like note that it exists, right? Yeah, so like for example, like 2, right, which would be the third capture group would be here. It's just 4 digits, right? So notice all of these values are like 4 digits. And then finally, if there's no matches at all, then it'll just put nans. Finally, there's regular expression dot sub, which, as the name suggests, substitutes text, right? You replace, this is pretty much the same thing as dot replace, just with regular expression strings, I guess, right? You replace the text with all instances of pattern, and you replace it with this input you put in here, right? So if I have this like div thingy again, right, then my pattern is this, or like basically anything contained. This is basically saying anything contained in like these 2 greater than or less than signs, and this just means anything except for these two characters, right? Oh, sorry, anything except for this character right here, then 1 or more times, right? So this would include div, this would include this section here, and this would include this section here, or this section here, and this section here. Then I say I replace it with nothing. Okay, so basically saying I'm deleting it, right? So what this will output is just all the pattern matches that got deleted, and okay, we'll output what's left, right? So in this case, this string moo is all that's left. So this will return moo. And very nicely, this is also supported by series.str, right? So I can call on everything in the column and it works basically exactly the same way, where I have a pattern, I have this, and I don't even know if you have to specify this, but I think you might as well just do it for safety, right? You have a regular expression equals true, and this will return a series with all instances of pattern replaced by what you inputted here, right? So if we have this like HTML table, and we call string.replace on this column with the exact same pattern as before, right? And replace them with nothing, there should not be a space here. It's a little typo. Not be a space here. So here, it'll look at this one column. It'll see every time this matches, then output what's left, right? So in this case, S14 is move, right? And then so here would map to link, and here would map to bold text, right? So you're allowed to do the substitution on every column, right? So intuitively, this is quite nice, right? So like, for example, in the CA California example, right, I can simply just replace CA with California, and I'm simply done. Then I can merge the 2 tables together, right, for example. And this is just one function call, by the way. This is a very simple 1 line of code. I just altered every single thing in my column. This is another table of like a brief overview of the different regular expression functions we can call. Yeah, there's like a replace, right? Split. Oh wait, is it dot? Oh, sorry. Okay, it's not dot sub. It's dot replace. I forgot about that. Sorry. I think in Python it's also called dot replace. So I don't know why regular expression changed this to sub. But yeah. Okay, so for our intents purposes, you probably don't even need to know like re dot sub. You just need to know dot str dot replace. You want to do like the column operations. It's like the idea of what we're doing here, basically. That's actually it for today. Next week, we'll go over the solutions to assignment 1. As mentioned before, if you don't have assignment 1, message me on Zoom right now, or like just text me, literally. And as mentioned before, we will pause for 2 weeks due to finals and AP tests after next week. All right.